And we are gearing up for our last presenter of the day. So we have Martin coming up here with his modular storage tower. So we're going to go ahead and get that set up, and then he'll be able to tell you more about it.
So when I started this project, which was kind of piecemeal, as you can tell, in fact, just by calling it modular, that helps to break it down. I can remember somebody coming up in the shop and saying, you know, what are you building a droid? And it was a kind of a project of necessity to help me to, you know, cut the clutter of things that were just scattering throughout my work areas. And I thought, well, I can use that as a segue for this presentation. And that part led me to a little bit of research on who it is that we all, you know, love dearly, R2-D3, and kind of basing the name of my presentation what I thought was off of that. But I don't know how many people probably go along with me. Probably everybody would not balk at, you know, thinking R2-D3 was a second-generation robotic droid. And what was striking to me was that 4 years earlier from the first release of Star Wars in 1977, that the origin of that acronym probably is traceable to a sound engineer who was working for Lucas on a previous movie, American Graffiti, in 1973. And they think that the acronym came from the labeling Reel 2 Dialogue Track 2. And that kind of was a bummer. I was like, oh, man, that's not very magical from what we think of, you know, after all of the Star Wars series. And I thought, if they can go out of the lane that far with their naming, why not? And I thought, this is Reel 2, and it's got 3 dexterous modules to it. Right now, this one is really heavy, and I won't stack it onto here, but that's what it looks like when it's all together, and it's the destination. We can put it together afterward to show you its height. A little bit unstable on that table going up all the way. But this is, like, from a roadmap perspective, us taking a trip backwards in the rearview mirror. We're going to kind of unpack it. So how it is that we do that is sort of hard, because I remember when Jordan, you know, put the email out about this, you know, about, you know, we want to know about the details of the process. And I've seen some pretty high-speed stuff going on here. You know, people that are, you know, into, you know, very high-level engineering, especially with the 3D printing. And I was thinking, wow, well, kind of a bummer, because I don't have a systems engineering plan for this thing. It was a system of damage control based off of, you know, the kind of urgency to rapidly prototype, you know, what it is that my goal was to cut the clutter and to help me get into a one-stop shop kind of a place that I could centralize things that I needed every once in a while, which for the time being were just everywhere. And I would play games with myself saying, well, I'll remember, you know, that in this part of the garage there's the, you know, plastic stuff, or this side there'll be the bigger parts and stuff like that. But it just, after a while, you know, it catches up to you. And when I started doing this for the first stage, I was realizing, man, you know, this is something that's doable. And it started with the little part here that's called the assorted shims organizer, which is this one here. And what I was doing was looking at the wood pile scrap in the shop, and honestly, just like in a Lucas or Spielberg Toy Story movie, the scrap was just, you know, like chirping away like R2-D2, you know, humming and saying, I can do this, I want to do this, I want to be a drawer or a drawer pan. And I'm going to pass this around as an example, because I think, you know, it helps to show this is something that can be really quickly and easily put together. It doesn't have to be fancy. And after I saw that come together, I was thinking, well, I would like to have something to help centralize this kind of shoring that was just all over the place in my garage, and it's all different sizes. I said, I'm gonna get it to something that's consistent and that I can take and put back together in a index scheme. I use the laser to do things like, I think you can kind of see here, I can put the stuff all back the same way so that I keep it in this small tight space instead of all over the place. And the laser was also fun to kind of come up with these extra little frills. They're not really functional, the little pine trees. But that was a point where I said, man, I can go all the way. And there's another class of scrap that I had that I still use. They're not just things that you just throw away. Just miscellaneous things like tubing and kind of little pieces of wood that come in handy for a project now and then. And so I came up with this third module, which is something that's a different material from the first two stages. And we'll talk about that more because that's where I explored things that were a little bit out beyond stuff that I was picking up from the first set of classes that I took. This brings me to, kind of a synopsis point of what the whole trip was for me in putting this together, which was, this set of steps. But a journey is something that is a beginning to your destination, and the real beginning for this is that. So the getting off the launch pad and getting into orbit is based off of this, and that's what you can do here. So for the metal parts in particular, the MIG welding class, the metal safety class, absolutely you got to have it. And you'll notice that if you get a chance to come up and look at this, there's parts that have been bent and folded. There's parts that have been welded. And that whole idea about synthesizing or kind of fusing the things that you pick up in one class with another class and another class, that's what I want you to get. Is that if you're thinking about coming here, don't do it just for one class. You look at your schedule and you think, well, can I do this? Can I, maybe I'll just take one class and get started. But I'm telling you, tumble it and get that bridging, and you'll be able to really go to town. So that's, I think, the really key point about when I was asked to do this presentation. I was thinking, well, this is kind of ordinary looking. This isn't spiffy or anything like that. To me, it works. And when this presentation is over, my little droid is going to come back with me, and it's doing its job even right now. But for you guys, what I want you to do is to think about your own projects, which will start off kind of like mine, where you have some idea that you want to start with to get at something useful. In this case, I'm showing how I started with perforated steel for this part, which I just barely learned about, that the Metals for You place in Round Rock had, that I was thinking kind of like that because it lets light in. It can drain oil and solvents. So yeah, this is something that is kind of all-purpose. I can see stock that's masked in through here because of the way light comes through, which has an important kind of consequence to the way that you tool this stuff. But how do you do that? Like, this is for the whole project. This is it's beginning and end. It's this destination. But each part of this project has sort of like a enfolded journey from the stock to the final transform shape. And this is an idea of a map for your sub-trips that you're taking with this, starting with making a rough sketch of what it is that you think you want to get at, making some estimates for parts, going and purchasing the stuff, and making a to-scale template in the case for this third module, so that you have to do that in order to really see what the amount of material is that you're going to use of the stock that you went and got from a rough guess. But there's some tricks that you don't know about when you get into projects like this if you haven't worked with the materials, whether it's acrylic or certain kind of wood, and you need to listen to when that step of the process is talking to you and saying, maybe I can do something different, adapt my plan a little bit to make use of that discovery. And for me, and you're working with the perforated steel, which I found the most kind of fun discovery in this project, was that if you look at it without any kind of bearings, you can go cross-eyed to it. But after you look at it and you go to the break, shear, and roll machine, and you have to start processing this stuff, what you key off of right away is that there's straight lines that show up. They happen to be 1/8 of an inch in diameter perforations along, spaced 3/16 of an inch. But you already are picking up on some detail just by me standing here talking about it, noticing some details you wouldn't have otherwise. That, for example, man, there are these hexagon seeds or kernels that are prolific throughout the whole pattern. It's like this recursive, fractally space that is loaded with internal and external 30-degree, 60-degree, and 120-degree angles that you can go to town with and get a lot of mileage out of if you go back to your material and you look at what it is that you were starting with here in your kind of dream template, saying this is what I want to get at. But from the last couple of times that I went to try and make tabs or cuts, I noticed that the machine was kind of barking a little bit, or that these bends were just not quite symmetrically all lining up. What you want to key off of is that previous slide with those tricks that you see. Wow, if I make my alignments along those perforations, most of the work is through air. These are lines of least resistance, and this is just a little kind of special story about the one material, the perforated steel, that whether you're working with whatever, look for those kind of messages in material. Just like I said, at the wood pile, stuff is just sitting there in the scrap, saying, yeah, me, pick me, because I want to be a drawer pan or whatever. Are you that if there's kind of tooling things that you want to do, people are probably wondering, why would I want to have a shim drawer for shims? Well, this is an idea that consolidates some of the steps for the cabinetry work that goes into the wood parts of this, that show tenon jointings that you can take a class here for, and how you can kind of use shims to true up stuff. So that's a kind of a step beyond the simple drawer. And these are examples here of the perforated steel. If you haven't seen it, it's something that is very interesting. It's about 1/16 of an inch thick, and that if you fold it and crimp the edges, it becomes 1/8 of an inch. And I'm telling you, it's incredibly strong. It's structural. And you'll see that in the pieces that you look at. You can see the beginning of a fold that I have a picture of, and then the completion of that fold. And I realized, wait, man, at first I was thinking I'm going to need a lot of stock for reinforcing the corners and stuff like that, but it's enough. And so this is pretty much a synopsis. That's all I'm going to have time to go into. I think the more important part for you all is not to think about, oh, okay, Marty's told me, how I can, build, this thing, but that there's ideas for you about how to build your own map. And that's what I want you to take away, is that there's variations to that, and you should think about how can I go build something that's useful for me and change. What is that guy talking about? I'm going to try this. And it's fun. This is the creative process. And in that journey that you're going to take, I have some tips for the road for you. Take the classes, and when you do, take notes. You'll get RAS for it because it's just not common, but it's really handy to know things that if and when the instructors aren't around and you come in the shop and there's nobody there, where's the fire extinguisher at? How do you turn on the dust collector? Things like, where is it that you need to wear a full face mask? What equipment needs to have, the coolant system working on it? So I still think taking notes is cool, even though I got RAS for it. And my last tip is for you all to take and save your scrap on these projects and sort it so that it's ready for your next projects, because I'm telling you that you don't even know, you haven't even thought about it until you finish your first project. There's loads of stuff that you're going to go on to that could be even more useful than the first thing that you built. So catch those kind of creative waves, tides coming in, surfs up, and go see what you can make. And that's what I want to get across. Don't make this. This thing is going home, do its boring job and stuff. But if you follow that roadmap that I told you, tons of stuff you come up with. And I also have some, if for the people that are still thinking about wanting to become members here, coming up and see me. I have some trip idea tickets for you, and I'll stop there, Jordan. Sorry.
What did you use to bend the perforated steel?
So, good question. This is a brake, shear, and roll machine right here, and it is very. I mean, at first you look at it, you think, man, is this like from the 30s? Probably, actually. But despite that, the way that you can take and adjust and change out, the angle breakers there is phenomenal, and you need to because of the way that the bends, come into play and kind of compete for space at which you're trying to complete folds and stuff like that. Once you get the form started of whatever it is whether it's a complete fold over, you can tweak it with the hammer and anvil. You can close it up all the way. So it's a kind of a multi-step process, a sort of successive adjustment, and you can undo that. You can take a screwdriver or a chisel and just kind of pry it open and say, no, it didn't line up along that line of least resistance. I want to get it right. So it's kind of forgiving. The material is like really cool if you just pound it back out and retry it.
Yeah, I assumed you used that to get some of the bends, and so you said it was with a hammer that you closed it? And
Yeah, because you can't close it all the way on the brake, shear, and roll machine.
Okay, cool. Yeah, I was wondering that too.
Yep. Which is kind of cool because you don't mess yourself up in one step.
Yeah.
You're really going to mess up good, man, I'm going to do it twice. It's like, no, don't do that. But you can recover. So that's doable. Thank you.
Thank you.